first off, today's going to be a traditional lecture. Once I get past this administrative stuff, I'll be talking about how to modify sequences. But by traditional, I don't mean I'm going to do PowerPoint. The way I've always done lectures are the way you've seen them on video, which is that I live code examples, right? The only reason is that I feel like that the sense I'm getting is that students are right now have a ton of work to do in other classes. So I'm not going to give you additional work over here. The other thing I've heard is that it's like, it feels like we're learning a lot of random stuff. Well, this is the time where we start tying it all together, where it all ties together. The homework will look very difficult. This upcoming homework, the Hurricane Tractor, it looks insanely difficult and complicated. But here's what and I'm going to paraphrase what students have told me, okay, from last semester and the semester before that. Well, it looked really hard, but once I sat down, it was actually pretty easy. Well, it looked really hard and really difficult, and I really didn't know where to get started, and I worked on it for an hour, just met. But once I actually sat down and started thinking about it, and figured out and started going through step by step rather than trying to do it all at once, it took me about 20 minutes. So that program is actually fairly straightforward once you figure out what you're doing. The hardest part is trying to remember, wait, is longitude which should I put in X and Y, longitude or latitude? And if it's not working, try swapping them. So, all right. Next, grades. Over the weekend, I wrote a Python program that basically took the grade book I downloaded from Runestone, the grade book I download from Canvas, merged the two, and then I re-uploaded it onto Canvas. So a couple things here about that. First, if you've got, be sure to check your grade to make sure that you're on Canvas. If you've got a bunch of zeros for some reason, just let me know if there's a reason for it, right? Let me know if there's a reason for it. It could be that it missed you, right? It could be that it didn't find you when I was going through stuff. So that's just something I need to figure out. I'll show you the code at some point, but it doesn't really make too much sense for you right now. I posted an excerpt from it on Discord though. If it says you're doing fine in Runestone, that's really what matters. And I should be updating Canvas about once a week so basically I'll download from the grade book and I'll update it into Canvas about once a week. Grades are probably best by email. Let's see. So the Runestone grades will change if you go back and do them, right? If you go back to an assignment and do it, it will change it once I run the grader, and then Canvas only updates when I do this process, which I'll probably do once a week. Now, there are probably Runestone assignments that say you have 0 out of X. That's because I haven't really graded anything past chapter 8. I didn't run the auto grade error on anything past chapter 8. So I'm going to do that on Friday. I'll probably do that. Attendance didn't start? No. Let me do that now. Okay, so Score Me, I don't know why it's missing. I really don't. I will have to send a message to the devs there, but Score Me isn't necessary for your grades. It just simply gives you a preview. It simply gives you a preview of what your grades are. It says, this is what the grade I would have gotten. The thing that gives you a grade in the grade book is me running the auto grader. Okay. So if we go back to the readings and you do them and fix them, the grade should update when I run the grader. Okay. Now, what is with the 12 or 14? I just haven't run that yet, except for like 1 or 2 students to test it. So the main reason I put it into Canvas was to give a wake-up call, just to make sure that you were seeing, hey, is there an issue with your grades? Because the vast majority of students have have a high A in this class. Oh, the pig, and then somebody says pig and Hawaiian. Those are in the upcoming weeks. Hold on a second. Let me just check. They are, I just didn't alter the due date for them. They should be, they're not on the module, so don't worry about them yet. I import the pig and the Hawaiian, I imported them from spring, so they just haven't percolated. I just haven't attached them to the relevant modules yet. Pig will go with the dictionary homework, and sorry, pig will go with what module are you even on now? That is an excellent question. So let's go into this. Here we go. Let's go ahead and start screen sharing. Okay, return to meeting, screen share. Okay, screen sharing, modules. Let's go over here. Currently, so lab for Mario Cash and Credit was module 6. So we're module 7, sequences and file reading. So here today, I'm gonna go over how do we modify some lists and things like that. So what kind of, and talk about things with aliasing, and also probably get into file reading a bit. Your assignment here is a hurricane tracker. Module 8 will be the Hawaiian pronunciation guide assignment, and then module 9 will be pig, which is a dice game. And then once we get to module 10, we're going to be basically working on probably internet-based stuff, and look at, and probably I'll be reaching out to the CS50X curriculum to give you that. So after that, I'm going to be giving you tools to make really cool projects after that. Module 9 is all about making things that are going to be super useful for other classes or doing homework. All labs need a demo. You can demo with me today if you need to. But in general, this should tell you what's going to go on. I've just been very bad about this week. Since I will be doing the traditional lectures, we've got your readings and exercises. This is your lab. And then I'll probably have another quiz this week. Somebody asked me when the first test was. We don't have tests in this class. I'm just doing the quizzes, except for the final exam. So yeah, because I thought it was pretty clear about that. Well, sorry, yeah, well, so the only reason I'm holding a final exam is because I've been told I'm required to, or I've been told that I should be required to, even though technically I have full read them. How difficult is the final exam? Probably not too difficult. I'm gonna figure out what to do there. Yes, you'll get a study guide for the final. Depending, I will check in with Jean, and if I can turn the final project into something, I might do that, but we'll see. Okay, so let me see how ambitious people are with the final project, and I might be able to get see what goes on there. So the in-class exercises, no, I just have to go through and mark them as completed. Okay. So with that being done, so first off, I've just recently installed, there is no midterm. There's just quizzes. I figured basically doing a quiz every 1 or 2 weeks, that makes more sense, especially since there's trying to get 150 students, some of which who might be sick or quarantining or otherwise have issues going on, to try to coordinate them to take an exam at the same time does not make sense for this format. It does not make sense during a freaking pandemic, right? So short quizzes are what I care about. Assignments are what I care about, right? I just need to assess how you're doing. And if there's an anomaly where people get super high grades this semester, then mote be it. This semester I'm trying something different. If the classes are, if I have to adjust difficulty, I will do so as a response to this semester. as opposed to trying to wildly do it during the semester. So let's go ahead and adjust my font size over here. So again, I like to be super readable. Ooh, there's a screencast mode. Let's see, view, appearance. Let's see. So, where is this screencast, this mysterious screencast mode that you were talking about? Appearance. There's full screen mode, there's Zen mode, which I know what that is. That's just super minimalistic. Open view. Okay, I'm gonna assume it's lying to me until otherwise proven. So we're just gonna go with the 28 font size until, oh, that's a console. So, and then editor font size, 28. Let's see it. That looks fine. There we go. So yeah. And then what was the other one? Terminal. Terminal font size. Bump it up to 28 as well. Right. So I just installed Windows. Now, one of the things, if you're in 1001, okay, if you're in CS 1001, like, or CS 1001, I should be doing a guest lecture there on the 23rd. So I'll be talking about basically making computing a more, or making working on a computer a more pleasant experience for you. But one of the things you should get yourself to do is to basically embrace Murphy's Law and understand that things that can go wrong will go wrong, okay, are going to basically be a thing that happens. And so you should be able to basically get a computer up and working in like 3 or 4, in like 3 hours, depending on it. I do data structures. I used to do 1068. Professor Fiore does 1068, and he's a wonderful professor. So he does the next class after this, and then I do the class after that in Java. So, but Professor Fiore is wonderful. Okay, he's the only way you can piss off Professor Fiore is by basically not showing up to a lecture for about 3 weeks and then asking him what's been going on for the past 3 weeks. So, like, you gotta reach as he does not appreciate lack of communication. So let's go ahead and actually get into the lecture now that I've answered questions. If we have more questions, especially about grades or just grading in general, wait for me after class. So let's go ahead and talk about transforming sequences. So we've talked about sequences and their mutability. So let's go ahead and create a new file to save as. So I'm going to put this in Classroom. Let's see. Yeah, if I can just remember how to read and do things in alphabetical order. Fall 2020, let's go ahead and do sequences.py. So I'm going to put a bunch of code segments in here. So, right, we've learned that we can change that basically if we create a list, such as this, right, 1, 2, 3, 4, 5, right, this is what we call a mutable sequence. Whereas if we're dealing with strings, they are not mutable. Right, and by which I mean mutable is just a fancy word to make us sound really smart, which means that we can change a list, the items in the list. So I can run this code over here, and literally I'm just dumping it into here. So there we go, and then we can see, hey, there's the entirety of L at the bottom of the screen. Right? Let me go ahead and, okay, so we see that we were able to change L. But the minute I try to do that to S, change hello into bellow, by doing this, it's just not going to work. Right? It will give me a string does not support item assignment. So lists can be changed. Okay, so today we're going to learn about different ways that we can change a list. All right. The first thing we can do is that we can learn how to add elements to a list. Adding elements to a list is super simple. So here I've got L is 1, 2, 3, 4, 5, right? So L is 1, 2, 3, 4, 5. Let's go ahead and add another item to L using append. Append just slaps an item right to the end of a list. So let's go ahead and put in append 6. L dot append 7. Notice I'm not doing any assignments statements whatsoever. I'm just doing append. One of them. So print L. So 1, 2, 3, 4, 5, 6, 7. So appending 6 and 7 adds it to the end. Now notice I didn't do a single assignment statement. Okay. I didn't go L is equal to L dot append 6 because other, that's, you feel that's, and I make that mistake sometimes because you feel like, oh, well, with strings, whenever I concatenate strings and put them together, right, I have to store it in the new thing. But append doesn't do that. Append actually returns none. So if you do that, you'll get an error. So don't, just basically remember, don't do this with append. Append just simply slaps it onto the end. All right. There's other ways we can insert things. I think if we do L dot insert, we can say, hey, given an index, I'd like to insert something. So I'm going to say index 2. So right, this is at index 0. This is an index 1. So I'd like to put something at index 2. And let's go skip a few. And let's go ahead and print L. 1, 2, skip a few, right? 3, 4, 5, 6, 7. So what it did is that it said, skip a few said, hi, 3, you're at index 2. I want to be at index 2 now. So you go and scoot. And in fact, everybody else scoot, right? So when you insert something, that's different than just changing something in a list. It makes everything scoot over. Pretty cool, right? All right. Now here's something that I find kind of horrifying in Python myself, which I suggest not doing, but you totally can. L0 is equal to, actually, hold on a second. Actually, no, I'm not going to do that because I don't think it works the way I think it does. So I think I'm misconstruing two things. So we've learned how to put things in. Putting things in, just simply add them. You use append, right? There is also doing concatenation with a list, right? We could totally do L plus 8, right? We could do that. Oh yeah, why didn't it print out with 8? Because gotta put that there, right? We can just simply update. We can create a new list and put that there. Notice that this creates a new list. This does not, right? This is saying change this list. This is saying take this list, take this other list, make a new list out of it, put it in here. It's a subtle difference. Subtle difference. So this is adding to a list. You're going to use you're going to rarely use insert. You're going to use append a whole lot. Because if you're iterating through something and want to store things in a list, you're just going to say, start with an empty list and keep adding stuff to a list. So append gets used a whole lot. Insert, not so much. But it's important to know that you have that option. Also, what you have an option for is deleting things. So we've got 6, 7, 8. So we've got 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Right? So let's go ahead and get rid of skip a few. And it looks a bit weird compared to all the other stuff in Python, which is that we say del, and then like, I don't get why it works like why they have it coded like this, but they just do, which simply says it's the word del, and then you have a space, and then the item you want to delete, or you say, I want to delete not A2, L2. And so now if I print out this, it deleted that item from the index. I deleted the item at index 2. Okay. But what's cool in Python is that you're not limited to deleting one thing. So first off, I rarely use delete. Once something's in the list, I generally don't want to remove it from the list. And in fact, a lot of times I'll just use the remove. You can use something called remove as well. So delete, says given an index, I'll remove this item from that index. L.remove, notice it says takes in an object. So here I put in skip a few. Given an item, and this does kind of its inverse. Given an item, I will remove the item. And yes, I'm recording this, and yes, it will be uploaded. So don't worry if you're frantically trying to take notes. Okay, so what we've got here is that we've got basically a way to just tack stuff onto the end, a way to put an item in anywhere, a way to remove a specific index, and a way to remove a specific item. The last thing I want to show you that we can do is this over here, which I'm just going to yoink from our textbook, is this. So we have a list, A, B, C, D, E, F. Delete the slice 1 through 5. And that will delete index 0. Sorry, that links index 1, 2, 3, 4, up to, but not including 5. So you can delete a slice. I can count on my finger the number of times I've done that. I actually could count that on a blind butcher's fingers, the number of times I've done that. So, will you need to remember that for an exam or a quiz? No. Really just know how to remove, really append is the big one, and then remove is the other big one. So now I also want to just kind of show off something very interesting that students get confused about as well. Now that, and this is true for lists and strings, right? So A is equal to, let's go with and say A is equal to hello, and B is equal to hello, right? So they're the same string, right? These two things are the same string. They're both hello. So if I print A equals B, it'll print out true, right? That makes sense to everybody, right? Those things are the same. This is not a trick question. A is equal to B. Makes sense. But if I do this, so this is actually a special variable we haven't seen yet, is, or a special keyword we haven't seen yet, is, and there's some use cases for it. Okay, for strings, that's not a good example. I forgot that that's special for strings. So let's go ahead and change it to lists. Okay. 1, 2, 3. B. 1, 2, 3. So this applies specifically for mutables, things that are changeable. A equals B. This means that A and B are the same, refer to the same, that have the same items, right? This has 1, 2, 3. This has 1, 2, 3. If I were to change it to 1, 3, 3, or 1, 3, 2, that's probably an even better example. It says false, right? Because 1, 2, 3 is not the same as 1, 3, 2. They've got the same items, sure, but what we care about with lists, right? What's important about lists is that lists have an order to them, right? The order that you set stuff up in is a different list in which the order you break things down, right? So now let's go ahead and run this again. They're both 1, 2, 3 again. So you've got A is equal to this amount, B is equal to this amount. They have the same values, but then there's this A is B statement which says false. Now what it's asking is, do A and B, are they referring to the same variable? Or sorry, are these variables referring to the same item in memory? Are they aliases of each other? Are A and B the same? Are the names for the same thing? And the answer here is no, they are not names for the same thing, because A is 1, 2, 3, B is 1, 2, 3. But if I were to change A by appending an item, right, add 4 to it, A, print B, so I print them both, right? Changing A did not change B because the variables point to different items, right? Let's go ahead and grab the magic pad of doom so that I can do a whiteboard. Also, let's see, actually, have I set this up on my computer yet? Let's see. Give me 1 sec. I don't know if I set it up properly on my computer, which there's always something. Let's see, do I have? Nope, I did not install the drivers for the Wacom tablet, so that's okay. That's okay. Don't need it. Don't need it. So annotate, right? Essentially, A and B, basically, they both have a list that they're pointing to. 1, 2, 3. And then 1, 2, 3. Right? That's initially what we do, right? Really should adjust that tablet, but oh well, I'll have that for Thursday. So when I append 4, I'll just simply adding a 4 right over here. Trying to do this with the mouse is actually pretty terrible. So now, actually, when I have, but I'll still need it. So now if I change it to this, A is equal to B. Now something interesting happens. A is B. So when we do this, right? So we say A is so line 28, we do this. We set up A to point to this over here. Go ahead and do an eraser, right? Sorry, it's messy. The drawings are better on the textbook. And we set up B to do that, to point to that list that we create in memory. So now the question is, when we do A is equal to B, what happens? Well, what happens is that we erase this pointer, this reference, and says B is actually going to store this list as well. Right? The thing on the left gets stored in the variable, sorry, the thing on the right gets stored in the variable on the left. That's what happens over here. So we store that in there. So A and B refer to the exact same thing, which is why we get a second true down. Make sense? And so when I append 4, because they're referring to the same variable, we get 2 4s over here. I know that's a bit tricky, but it's part of the reason why this works. So here, right, from your textbook, if we look at objects and reference at 9.4, objects and references, we've got this statement over here: A is equal to banana, B is equal to banana. The Python interpreter can do 2 things. We can say, hey, A and B are their own version of banana, or A and B point to the same variable, right? And if it does, and the reason is that Python could be optimizing, right? From the point of Python and the point of and memory, it doesn't matter if there's one word for banana or two words for banana. Well, it does from the point of memory, but from the point of like, logically programming something, it doesn't matter because it's immutable. So if we run this, it says, hey, they point to the same banana. And they have their own ID, which is pretty cool. Which is basically a variable that basically says what this variable references. Every Python gives every object a unique ID. So what it's asking is, hey, do those two things have the same ID? I actually didn't really know too much about the ID stuff. It rarely comes up. Let's see. But the point being is that just be aware that when you mess with a list, right, that if you have two variables that are referring to the same exact list, then you're going to get then you're going to change the list. So let's go ahead and take a look. Let's see. And that concept is what the book refers to as aliasing. In fact, all programming languages refer to as aliasing. And let's see. So there's a bunch of other methods, but the append and the insert are really what we care about. Now, the reason I wanted to go over that was because, honestly, it's very useful to get the handle on these stuff when we go into files, which honestly is the more exciting bit. So check out the lists in your textbook. But let's see. There's a couple other things I want to tackle for it. What if you want to make a copy of A? What if you want to copy A so that you have the original, and you want to you make changes to it, you don't lose the original, right? What if you want to do that? Any suggestions on how to make a copy of A? Ooh, list of A. Let's see if that works. List of A. Wait, let me remove this variable because that will undo anything we do. That is a fairly good idea. List of A. That is a really good idea. So any other suggestions? Because that is a viable way to do it, which simply says, right, all that says is given this thing, turn it into a list. Well, turn this thing into another list, creates a new list. It's a fantastic idea. There's a simpler way, and one that's pretty powerful, which is a.copy. Let's see what copy says. What does copy do? Does it create a deep copy? Hey, .copy. Probably. But what I like to do, and what's done a lot in Python, is to use slice notation. So this says, go from the beginning to the end, and basically take a slice from the beginning to the end. So slicing is pretty cool. And the reason for it is that you can also do this. So this comes up with something completely different, which is the list in reverse. So think about what this says. From the beginning to the end by -1. In other words, go backwards. So the easiest way to reverse a list is to do this. If you just want a copy of the list, do this. It's a very easy way to do it. And let's see, what other cool methods do we have for lists? There's sort. And so let's see, you can sort a list. So here, given, well, we've got 1, 2, 3. So let's go ahead and do a.copy plus A dot copy in reverse. So here we're just saying, so this should be 1, 2, 3, 3, 2, 1, right? And now let's go ahead and say B dot sort, which takes it and will sort it. Make sense? So sort is pretty useful. That's about all the useful methods there are. Now, let's see. Sorry, I feel like I'm about to sneeze. So, excuse me 1 second. All right. What does sort do? Again, it sorts. Sorts is fantastic. So let's go ahead and actually go to a term. Let me go ahead and go to a, let's go ahead and basically just simply load this up into here. Let me go ahead and take this guy and load it up into here. So here we've got B. Oh, right, I have to shove them both in. So there we go. A is equal to that, B is equal to that. So we've got A and B, look at the bottom over here, B. Okay, so now let's go over here, and now we can see that B is 1, 2, 3, 3, 2, 1, right? So it's 1, 2, 3, 3, 2, 1. So what sort does, if you call sort on it, is that it modifies it to be a sort to sort it, put everything in order from lowest to highest. Now you might be wondering, wait a second, does that work for everything? Today. All right. Hello, how are you today? What am I missing here? Oh, I missed the quote, close quote there. So hello, how are you today? Words dot sort. Now, if we take a look at words, are hello, how today you? It sorts them in alphabetical order. So, God help me if though I haven't really thought about this. What happens if I do this? I don't know what happens, so I'm actually interested to see. In Python, there's protection to keep you from doing this. Ah, yes. It says, hey, you can't sort an int and we can't figure out how to sort instance strings. Can you sort from high to low? Yes, you can. I forget precisely how you do it in Python. I always have to look it up. But the easiest way for me, but if you were to ask me in a pinch, how would I sort from high to low in Python? I would do the following, right? So, right? Words, hello, how are you today? Words dot sorted. Sorry, words dot sort to sort it. And then I'd say words is equal to words. And then I'd reverse it. Or words. Here we go. You today, how, hello, are. Now somebody asked, what about sorting this? How does this work? What if we've got a string and a number? And that works, unsurprisingly to me. And it says 1 are hello, how are you today? And this is because of the Ascii table, which is the basis for Unicode. So let's take a look at the Ascii table, which is the order in which things occur, right? This was made forever ago. and won't go into it, but you can see this is the kind of the alphabetical ordering of every single character. So 0 through 1, those correspond to the binary code for, or in binary, what you'd get for 48. So 0 through 9 rather, 48, and then 9 is 57. And as you can see, lowercase a is 97. So actually anything with uppercases will come before lowercases. So interesting thing to note. Okay. So that's pretty fun. So sorting things are pretty fun. So let's go ahead and actually put that to use now. So yep, list at the board, sort, reverse is equal to true. I thought you could do that for sorted, wasn't sure about sort. All right, so now let's go ahead and have some fun, shall we? So, let's see. So you'll still want to look at do the readings for chapter 10, but 9, but these are the important parts. What I primarily want to focus on is chapter 10, and with the time we have left, and I'll go into it more tomorrow because that's where students will struggle. So I'm going to go to Project Gutenberg. Project Gutenberg is pretty awesome. Oh, hey, they changed the website. Yes. Cool. Wow. Okay, I haven't been in here in a bit. So let's go ahead. So Project Gutenberg is, yeah, I did that, sort it and then reversed it. So Gutenberg is pretty awesome. It is anything where the copyright has expired. So let's go ahead and I'm going to download the complete works of William Shakespeare. Now, why the complete works of William Shakespeare? It's because what would be considered a large file. Do I prefer Firefox for any specific reason? I like Firefox because I can have a Firefox on my phone, which comes with, and that means I can have an ad blocker on the web browser on my phone. That's pretty much the only reason. And then I can synchronize them between. So let's go ahead and download plaintext UTF-8, 5.5 megabytes. Billy Shake here was he wrote a lot of stuff. Yeah, copyright is, author plus, I can't remember, it's 75 or years or whatever. So what you're going to want to do is you're going to want to if you go and download this file as well, you're going to want to download it into the same directory that you're going to be coding in. So for me, that's going to be putting it into users, and then putting it into my classroom, and then ITP, and then I'll put it over here into spring 2020. Oh, and I already have it in here, Shakespeare. So I'll just overwrite just to show. Oh, that's in spring. But I'll save it as shakespeare.txt as opposed to whatever the name was. ITP. I use this example a lot. So yeah, fall 2020, that's where we are. Okay. So it's a fairly large file. So one of the things I want to show when we open a large file is actually what happens when we open a large file, which is that depending on the text editor, it can chug. But this is a big file, which is why I like it. It is 169,000 lines and then some. So it's about 170,000 lines. So let's go ahead and see how we read files in Python. So the first thing we want to do is we're going to create a new Python file. And again, this is the really important part. Make sure it's in the same folder as the file you want to read for right now. There's ways to do it. But otherwise, so there's ways around it. If you don't put it, like figuring out what the directory is, but that's going to come later. For right now, let's put it in the same file to have some fun. Okay, so reading example. Now, if it sounds like I'm really excited about this, file reading was the moment I fell in love with Python. The cars in there are missing?
No, the cars are missing.
The cars? No, the colors. Oh, that means you got to reapply the colors with your with the water pen. You'll have to ask Mama where it is. Laser, here, take it with you. I'm teaching my class now. Okay, so this is the now Java reading a file was a pain always, because the way I was taught, you needed a file reading object which needed a buffer reader to read a specific file, and you needed a try catch loop, and it was a mess. Okay, so Python said, hey, if you want to open a text file, you just do this. Open, given the name of the file. That was Shakespeare.txt. Got to be case sensitive. That's the only catch. Shakespeare.txt, txt, text file. And then tell me how you want to open it. Because there's 3 ways we can open it. Right now, we just care about reading, but there's also writing and appending. So we're going to go ahead and do reading, which is just simply R. Or actually, I'm just going to call it text right now. Text is equal to open this, and now I'm going to run it to make sure it doesn't crash. And I'm going to print text. Right, which it says, hey, it's in this Shakespeare. Not sure what that was about. Okay. Oh, it was just something I did. Okay, anyway. So anyway, the moment I fell in love with Python was when I started experimenting. Any idea, without looking it up, how I can read every line of the text file and print it out? Think about how you would want it to work. Read is one answer, but without looking it up, I want to, for every single line individually, I want to read that line and print it out. You're all thinking too much and looking it up. There we go. For loop, right? Because that's the tool we know. And I basically tried this when I first started reading a file in Python. I'm like, there's no way this is going to work. Be cool if it did. And it did. Oh, okay. What's that? It says cannot decode that position. Character maps to undefined. Let's go ahead and see what that error is. Don't worry about downloading the text. Download some other text if you want to, or create your own text file for the purposes of this. It looks like it's having some issues with a specific byte. I'll get into that issue later, but let's go ahead and let me go ahead and download a different file to try that. I'm going to download Bram Stoker's Dracula, also out of copyright, which is why everybody and their kid is able to make a Dracula. Okay, so let's go ahead and switch it to Dracula because I don't want to try to tackle encoding issues in front of class. How does it know to print line by line? It doesn't so much know to print line by line as that's the default way it wants. It assumes you want it to be printed out. Make sense? And yes, it does split the entire text by new line character. Now, that took a while to print out, and that was Dracula, which is a much smaller file. So what is the R for again? It's for reading. So now the reason it's printing out space like this is because, well, every line has a new line character attached to it, right? So let's go ahead and open up Dracula. This is a text file. View, let's see. Can I show render control characters and view under white space. And I could do it on Geany, which is annoying. I don't know how to do it specifically in VS Code. But the idea here is that you've got, after Stoker, you've got a character here. Specifically, you've got a /n. Excellent questions, everyone. I will get to them, I promise. I'm not ignoring you. They are the right questions, by the way. So we've got a new line here, a new line here, a new line here, a new line here, and the book just renders it. And so when we read the file, it reads the new line and it prints it out, and then the print adds a new line to the end of it. So now somebody asks, what is the R4 read? Already answered that. What is the data type? Is it string? Is it a string or a list? And the answer is neither. Let's go ahead and see what it is. Print text. So me naming it text was maybe a bit of a deception, but hey, print type of text. So if you ever want to know the type of something, just throw it into type. It says it's an IO wrapper. What's IO? Anyone? Input output. IO is short for input output. So it is a text input output wrapper. In other words, it's just a wrapper around a bunch of text for doing input and output, right? So here we're saying specifically we want to read something. If we want, the other options you have are W for write and A for append. Write will create a new file or overwrite the file if it exists. Append just simply adds to a file as opposed to overwriting. They both have their use cases. When you're doing it, but for right now, reading is very common, and that's what you're going to need to do for your homework. How do you set your working directory? God, if I know. I don't do that. I just slap it into the directory that I'm currently working in. That sounds like you're using an IDE of some kind. For Python, I'm just writing a script, so it's just in the folder, and I have the folder, and then I have the same file in that folder. So, all right. So there are a couple ways we can do this, as other people's pointed out. You can store it all in one massive string. Let's create a variable called megastring is equal to text.read. And what that does is that takes the entire text or everything in the file and dumps it into megastring. This will be go. I expect this might not work in a hilarious way. Let's see. Oh, no, it worked. So they printed out so megastring holds all of this text, right? And I can show you, and I can prove to you that it's a string by using a string method on it. Like megastring is equal to megastring dot upper, which will make the entire text shouty. Right. So now if I, as you can see, it is the eve of St. George's Day. Do you not know that tonight when the clock strikes, and so on and forth. So interesting that it is not printing out everything. So let's go ahead and see where that is to. Did not know what to do. So, and let's go with, and taking for a crucifix from her neck. That's probably a unique line. So it only printed out up to here. So why did it print out to here? If I print out, let's go ahead and comment this out. It printed out the entirety of the file earlier. Does it have a limit on the strings? Wait, why isn't your file reading? Okay, so question for the people who are not having issues, file reading. What is the specific error you get? Because the most common issue with file reading is that it's not in the right folder. So let me go ahead and change. this to be extra large, right? You want both the Dracula file or the Shakespeare.txt file, right? No file or such directory in that. So you want it to make sure that, so no file or directory such. Are you spelling it correctly? Do you actually have it in the same folder? That's the big one that's what I would see, I would expect to have. Are you sure that it's also saved as a text file as opposed to right? Or is it is your computer doing something crazy like .text as a result? So if you're in Windows, hit View and hit File Extensions. That's just a useful thing to keep ticked. This should work in idle, no problem. You want it to be in the same file folder as one of the programs. So here, File, see Dracula, and you see, let's see, what was the file called? I think it was reading example. So see, they're in the same folder together. Right, they've got to be at the same level. It's not enough that they're like in the same folder in a subfolder. They have to be it. Right, okay, yeah, got to make sure it's the right file extension. Okay, file extension matters. So let's see, where was I? Okay, now, so the reason it printed out this much, so let me go ahead and print out, and Macs are okay, just a matter of differences. So let's go ahead and see. So I'm going to go up to the end, but I'm going to start at -100. So last 100 characters of this. Help produce our new ebooks and how to subscribe to our new email newsletter to hear about new ebooks. So this obviously stores the entirety of Dracula. But when I printed it out, it didn't get all the way to here. It got to taking a crucifix from her neck, offered it to me, right? Makes sense? So what's going on here? Well, here the problem isn't actually an issue with Python. And it's the reason I choose big files, like Shakespeare. The issue is actually, your text. The issue is actually with your text editor or whatever thing you're working with. This takes up memory too. This console out here, your output, that uses up some amount of memory too. And most things actually have a limit to how much you can print out. So here, let me go ahead and search the settings for a buffer. Right, controls the maximum amount of line the terminal keeps in its buffer. So it will do 1,000 lines before it starts throwing things out. So here, output, data science maximum output size, 4,000. Text output limit. Limit the amount of text the Python interactive cell can put out. I am using Visual Studio Code, but the same as, but you can do this in idle. The point being is that the reason I use this is that it just renders a lot nicer when I'm presenting, as opposed to idle. And I can use it for all my classes. So now, okay, there we go. So this reads the entire file. The reason it's not printing out the entire file is because there's only so many characters that can be printed out by my console. Okay, so another way to read this is lines, or let's go with all the lines, is equal to text dot read lines. And prints out a pretty big jumble. And again, it cuts off because there's a maximum amount we can print out in a single line, which is what this is trying to do. So what we're trying to do here is print out all the line. But what it does, what read lines does is that it takes every single file, sorry, takes every single line, physical line in the file, and makes each line an item in a list. So you've got a bunch of different ways to read a file. Okay. Personally, I like just using a for loop. I find that to be more structured. Let's go ahead and see something pretty common that we might do. Let's go ahead. I need to stop sharing my screen for a second because I don't want to violate FERPA at all. Let's see, some users. Andrew, yes, please give me access to my stuff. Oh, actually, I think I put it over here. Did I put it over here? I'm trying to remember where I put everything. So users, Andrew. What isn't working for you specifically? The reading, the file reading. So I'd have, again, with file reading, I have to take a look specifically at what's going on with your system to get an accurate count. I'm gonna go, rather than trying to give you a good example, I thought about grabbing the thing with all the grades in it. I'm gonna go ahead and what I'm gonna do is I'm gonna make my own file here to kind of show you an example, a common example. So maybe I have, so let's go ahead and save this. And I'm gonna save it as a new text file, which I'm gonna call grades.txt. So let's go ahead and put in some grades, 98, 55, 97, 100, 103, oh, so 130, because, you know, points are made up and nothing matters anymore. 78, let's turn this to 103. 91, 85, 72, 8, 95. Right, so let's go ahead and take this list of 14 grades, okay? And let's say this is a file called, grades. So that reading should work once you throw it into a for loop. You've got a text file, then you got to actually, you've got your wrapper to interact with the text. Now you actually got to do something with it. So let's go ahead and now do text is equal to open grades.txt, and we're going to read it. Okay. Oh, yeah, of course, I completely forgot about that part. Okay. So here, what I've done is I've created a new text file. All I did was like type this out and then save it into the same folder I'm coding in. Okay. Yeah. Okay. Chats. Where are my chats? Okay. There. Now you should be now you should be able to see, right? So I've got all the grades here.
The numbers more.
What?
I don't know. But the numbers, the water, so
Well, Mama doesn't know where the water is.
yes, to make the cars come back.
To make the colors come back?
Yes, but
Oh,
the brush is this like the water.
Oh, so Mama got you a brush for your for it instead? Did Mama get you a brush?
Yes.
That's
This like it too.
I'm glad that you were able to find a solution for that. I will check. Once my class is done, I will come downstairs and take a look. So let's go ahead and open up this text file. So what we can do with this is we see we've got 1 grade per line, and depending on your format, you can do different things. So for instance, we can do 4-line in text. So what we're going to do is we're going to read this line one at a time. Grade is equal to, so we can say grade is equal to.
Read this letter.
Annie? Annie, the last 10 minutes of class are being interrupted by laser. Could you please? He was very enthusiastically telling me and the class about a brush. All right, so let's go ahead. And what we're going to do is we are going to take every line from the file and convert it to an int. And I'm just going to print it out to confirm what we're doing. Let's go ahead down here. And what we can see is that we've read every line of the file. All we had to do the reading was open the file, say we're going to open the file. This is the wrapper for the file. I have various ways of dealing with it. Then 4-line in text. Grade is equal to the line, but then I've converted that into an integer. And then I printed out the grade. So if I want to find out what the average is of all the numbers in this file, I would just say total is equal to 0, right? We'd do our standard accumulator. And then I'd say, hey, let's go ahead and say total is equal to total plus grade. And then finally, what we're going to do is that we are going to print total. Oh, we have to know how many lines there are. So let's keep track of that manually. So lines is equal to 0. Lines plus equals 1. And that gives us the average of the grades. 80.57. So how do you get the whole thing? Right. So now since we're getting close to 4 o'clock to 3:20, I'll go ahead and summarize. How do you read a file? You can read a file in 3 separate ways, right? You can take a file and basically put it into a list using read lines. We can also do text is equal to open txt. Yep. There's a lot of different ways we can do this because there's different ways to open the file or different ways to get the data out of the file. So we can use a for loop, which is my preference because I like doing things line by line. You can, and often if you're going to be doing things line by line, might as well just write a for loop to do it. The next way to do things is that you can do text. Let's see if we can say, we can put everything into a big string, which is just the string, you know. String is equal to text.read. So read lines gives you all the lines and puts all the lines into a list. Text.read basically takes the entire file and it's as though you did this, right? It's the equivalent of doing a Control-A, copy, then doing megastring is equal to and then pasting it right here, right? It's the equivalent of doing that. So where basically you've essentially just turned the entire thing into a string, which is a really powerful tool. Don't get me wrong. And then here, if you want to read one line at a time and iterate over the file, you can do it like this. Makes sense? All right. Any questions about this so far? It seems like it's a hard thing to do, but all we're doing is just putting in like one or two lines to make sure that we can interact with a file like we're messing with a string. And that's really all it is. Messing with a file is the same as messing with a string. Although I should point out that there are as my last note, there are broadly two different types of files. Okay, there are text files and there are binary files. Text files are the things we see right over here, right? Which are basically anything that we can throw into a text editor like Python or like Python files, source code files, or .txt files, where basically it's just literally the text. However, right, let's go ahead and grab a PDF from here. Let's go to modules. Grabbing for loop. I'm going to just go ahead and grab this, save it to the desktop, and then I'm just going to kind of just drag it over and copy it into here. And would you look at this gibberish? So you're like, okay, this is text too, kinda. And then the PDF file you see, right? Some of it's readable, but some of these are like, it just makes you go, what? This is just machine instructions in binary for a specific program called a PDF or a PDF reader. So given the file, PDF reader can take this series of code and, you know, look at it. So this is what we call a binary file. We will pretty much never be handling binary files because you can't really mess with them easily. Now, Excel files are very common binary files that people interact with. But they're also binary files because of the various extensions and color codings that you can do with it. But fortunately, pretty much every single Excel file can be turned into what's called a CSV file, which is where we're going to pick up on Thursday, which is that we're going to look at Pokemon for those of you who have played it, and we're going to look at how to basically read different Pokemon stats. Specifically, we're going to look at a CSV file to read Pokemon stuff.
Can we look at Arceus?
At Arceus? I mean, it's going to be the entire Pokedex from Bulbapedia. So,
Gotcha.
you know, it's just kind of trying to show you that we have different ways of doing data analysis that isn't that hard to accomplish. And Pokemon because it's fun.
I concur.
All right. So I'm going to stop sharing. That's what I've got for today. So I will talk about your lab on Thursday. For those of you who have grading issues or have issues with the file reading or want a demo, you can stay behind. I will get to you. So just give me about 5 minutes to get a drink of water and to see what my son so desperately wants to show me. So, and then I will be right back to take a look at the at your code.